We'll now start with session 4. Session 4, which is about technologies and development pathways in the context of the North Sea energy system transition. Next to some modeling work and also the social aspects and more political and policy aspects, there are also, of course, technology and technological questions which are really important for the transition of the energy system in the North Sea. So we also have a session dealing with that. To begin with, we have a presentation of Eliana Lozano Sanchez. She is a PhD researcher at the University of Aalborg. She will give us a presentation about modeling of HTL-based biorefineries for advanced biofuels production and the prospect in integrated energy systems. So Eliana, can you let us know that you're there?
Yes, I'm here.
Welcome, Eliana. The floor is yours.
Thank you, Dirk. I hope you can see my screen now.
Yes, we can.
Okay, so good afternoon, everyone. My name is Eliana Lozano. I'm PhD student at Aalborg University. This is the title of my presentation of today, modeling of...
Eliana, could you go to full screen? We can see the PowerPoint application, but...
Okay, where should I go? Maybe here?
Yeah, this is already better. I think this works.
Yeah, no. Is this fine? I don't know if...
Display settings. I'm getting some feedback from the from the audience. The top one.
Okay.
Hooray! That works. Thank you.
Okay, perfect. Yes. So this is the title of my presentation: modeling of HTL-based biorefineries for advanced biofuels production. So today I'm going to talk about technology for the production of advanced biofuels. This is hydrothermal liquefaction technology, now HTL, which I'm going to explain further on. So advanced biofuels are one type of the different renewable transport fuels that are currently under study at EU level and are expected to play a role for the energy transition in the transport sector, particularly for heavy transport, so aviation and maritime. We have already some targets and legislation in place. Recently, the Fit for 55 package included aviation and shipping and specific targets for these sectors. Here we can see that the challenge is big. Actually, these technologies are expected to deploy very quickly after 2030. Advanced biofuels being used as transition fuels, and also the power to liquid fuels are going to be there. But the challenge right now is that there are not too many advanced biofuel technologies that are at a commercial scale, at a commercial level. So there are quite some at the demonstration scale. And the challenge is then to bring these technologies up to commercialization. So I'm going to talk about the HTL technology. This is hydrothermal liquefaction. Very briefly, it comprises two main steps. So we start with the biomass, and for my PhD, I work mainly with forestry residues and sewage sludge. In HTL, we have the presence of water, and we use it at very high temperatures and pressures to produce a biocrude. And therefore, we need hydrogen to increase the quality of this biocrude and to make it suitable for to be used as transport fuel. So going to commercialization, of course, we're interested in how this technology can be integrated into the system. It's not only about the biofuels, but also other products that we can integrate, such as excess heat, CO2, of also other materials that can be of use. Literature until now on HTL has focused a lot on the biofuel product. So trying to estimate what is the minimum fuel selling price and how competitive it can be with other technologies. But there are lack of studies that, for instance, look at the CO2 product, which is an interesting topic for carbon capture and utilization or storage. So we know power to X and negative emission technologies are expecting to play a big role in the transition. Also, excess heat from the process can be used for sector coupling. And during my PhD, I'm working on these aspects to see how these other products can have an influence on the minimum fuel selling price. So I'm doing a techno-economic analysis. Also environmental assessments. Here I show more or less the methods that I'm using or that I used. Literature study, a lot of experimental data already published or produced in-house at the research group. My modeling tools are mainly process modeling, but also coupled with economic evaluation and some environmental analysis. So as a result of my PhD, I have four journal publications, 3 of them already published. And today I'm going to tell you more about the last 2 due to time limitations. But these last 2 publications integrate also the results of the first 2 papers. The first one was more in modeling of the technology, the carbon capture step in the second paper, and in paper C and D, I did a modeling of a more integrated version based on the forestry residues and on the sewage sludge. So I will start with paper C. In this case, I looked at a centralized biorefinery with carbon capture. So in this simplified diagram, you can see we have an input, which in this case is forestry residues that we have. We have the 2 steps that I previously described. So the HTL and the upgrading step where we need hydrogen, and the box in the bottom which says select salt is the technology we use here to evaluate the carbon capture from the HTL gas, which is in a relatively high concentration between 60 and 80% for the lignocellulosic material. So as main products here, we have the CO2, and we also use the technology, the select salt technology for cleaning hydrogen, which is needed in excess in the process. So this hydrogen needs to be recovered for the economy of the process. And we also evaluated the production of excess heat. So the main question to answer here was what is the impact on the minimum fuel selling price and the greenhouse gas emissions for coupling the carbon capture step in the process. Here I show the cost estimation for the HTL baseline, so without the carbon capture. You see all the cost contributors there. Hydrogen is a big part, the cost is taken for green hydrogen. So the cost or the minimum fuel selling price is in the order of 800 euro per ton. When we include revenues from excess heat, it slightly decreases. Then in the bar at the bottom, we see when we include the carbon capture step, so we see a slight increase in capex, also increase in utilities and other costs. However, when we include the revenues from the CO2 credits under the European trading system, we see that the initial increase that we estimated in around 8% goes down to approximately 3%. So this is, of course, something that is not too bad, 3%. but depends on the CO2 credits and also how much heat we can actually integrate with the system. This is for a base case. We look at it also in a range, different minimum and maximum values for different cost parameters. So the result is the impact between -2 and +5%. So it's still within 5% increase. And in terms of the environmental performance, we see here for a standard HTL without carbon capture is in the order of 85%. The big bar or the big part here is the hydrogen, which has still some contribution due to the electricity emission factor. But in a scenario where we have a complete green electricity and we can capture and store the CO2, this technology can perform as a negative emission technology. The result is it's also similar or in the same range to what has been published in other papers, even though there are not so many at the moment. But we see it's in the order of -20 grams of CO2 per megajoule of fuel. Yes, so I'm going to talk about the paper D. Last paper is about the sludge valorization in an HTL biorefinery. In this case, we look at a distributed configuration of HTL plants, having the Netherlands as a case study, and using the fuels for the marine sector. Again, we look at techno-economic assessment and also environmental performance relative to business as usual, which for this case is mono incineration. So briefly, an introduction on the sewage sludge treatment. Well, this is a byproduct from the wastewater treatment plants. It contains organic and inorganic matter, but also contains some things that we don't like we wouldn't like to have, such as contaminants, microplastics, pharmaceuticals. So in general, at EU level, there are different technologies that we are using right now to treat or to dispose this byproduct. Key technology aspects for a sludge case are the destruction of contaminants, as I already said, and also more recently is the issue of phosphorus recovery. So I think Matt's already introduced this or talked about this before. We need to recover phosphorus from the sludge. Mono incineration, it's one of the technologies that is currently applied that is very effective in the destruction of contaminants, and also will enable after phosphorus recovery in a later stage, but also it has the highest cost. So we're talking about for the Netherlands, it's also the dominant treatment technology, as you see here, but it's quite expensive. So we studied distributed plants here because production of sludge it's already distributed. There are a lot of wastewater treatment plants in the Netherlands, which you can see in the picture. And also previous research has indicated that implementation it's not economically feasible in small plants. So including or approaching a configuration of regional plants, it's important to harness the potential of all the plants. Here you see an overall of the mass balance. So we took statistics from 2018 and used yields based on experimental data to estimate how much hydrotreated biocrude or marine fuel we could have at the end of the process. You can also see here the mineral product, which contains about 90% of the phosphorus. So phosphorus recovery is also an important aspect of this technology. In terms of the costs, you see here in the top bar, so that's only for the HTL step. the positive part of the graph, it's about the production cost, and the negative is corresponds to the sludge gate fee, which is the money you could get for treating that residue. So we see that it's quite big and could largely compensate the production costs. So here we're talking talking about a very or relatively low minimum fuel selling price, and then we will go to the upgrading step, again by implementing or by taking into account the sludge gate fee. The cost of the biocrude it's quite low, in the order of 650 euro per ton, which is quite positive. Yeah, something interesting to see here is that the transport has a relatively low share, so we could even try to increase the plant sizes in order to decrease the minimum fuel selling price further. Again, Monte Carlo shows that we are in a range. Yes?
Considering the time, I would like to ask you to try to move to the conclusions.
Yeah, this is my last slide.
Okay, perfect. Carry on.
Okay. So yeah, here you see more or less the range. Because we have below zero in some cases, then this indicates that there is potential for a more economic treatment compared to mono incineration. And this is finally the environmental performance, but I'm not going to talk about it. Maybe we could leave it for further discussion if someone is interested. So main conclusions of my studies are HTL has potential to be a negative emission technology without a significant increase in the minimum fuel selling price, and also for the case of the sludge treatment, it seems to be competitive with mono incineration fees, and also more beneficial from an environmental perspective. Thank you.
Thank you.